Hi, it's Naomi Andrick, and I'm working another problem solving with one-step equations problems. This is out of the set that has decimals. Um, so here we're given a problem to work. We have a chart to fill out, and then of course a graph to make. And our very first step is figuring out what the units of our problem are. So the problem states George wants to keep his lights on all day, but he doesn't want to waste energy doing it. So he collects aluminum cans and recycles them to make up for the energy he uses. Each pound of aluminum saves enough energy for him to leave his lights on for one day. So far this year, George has collected 21.3 pounds of aluminum. How much more aluminum does George need to collect so that he can leave his lights on for all of September, 30 days? So additional pounds of aluminum, of course the unit's going to be in pounds. So pounds. And then the number of days that George can keep his lights on, I guess the units there is going to be days, since we're talking about number of days. Maybe we let P be for pounds. And then for each extra pound, he can keep his lights on for exactly one day. But he already has 21.3 pounds. So it's going to be 21.3 for the number of days that he already has. Plus, for each pound, he earns an additional day. So, 1 more pound, we'd add 1. 2 more pounds, we'd add 2. 5 more pounds, we'd add 5, and so on. So, I'm just going to have 21.3 plus P there as my expression. Now, the first question says, how much more aluminum does George need to collect so that he can leave his lights on for all of September, 30 days? So, here we're given the number of days, but we're not given the number of pounds. So here we have, let's see, here we have a situation where we know that 21.3 plus P has to equal 30. So here we have this equation, 21.3 plus P equals 30. And then we could solve that equation, of course, by subtracting, let's see, I'm not sure what happened there, but, by subtracting 21.3 from both sides of this equation. Let's see. We have minus 21.3 over here. We're going to have the same thing, minus 21.3 over there. Of course, these cancel out. 21.3 minus 21.3 is just 0. So that goes away. Really wants to auto number. And then I can just simplify this. 30 minus 21 would give me 9. So minus 21.3 is going to be a little less than 9. In fact, it's going to be 8.7 because I go another 0.3 down from getting down to 9. So I get P equals 8.7 here. And I've got 1 point. Now, the second problem is if George collects 7.4 more pounds of aluminum, how many days can he leave his lights on? So here we're given the pounds, and we're given that it's 7.4 pounds. And then we want to substitute that 7.4 in for here. We'd have 21.3 plus 7.4. 21 plus 7 is 28. And then, of course, 0.3 plus 0.4 is 0.7. So I would have 28.7 as my number of days. The third question is if George collects 15.8 more pounds of aluminum, how many days can he leave his lights on? So again, we're given pounds and not days. So we put in 15.8 as the number of pounds. And then I would want to substitute this in here. I've got 15.8 plus 21.3. 0.8 plus 0.3 gives me 1.1, so I know I'm going to have a 0.1. And then my 1 carries over so that I have 15 plus 1 plus 21. 15 plus 1 is 16. 16 plus 21 is 37. So I'm going to have 37.1 there. Now I have 3 points I can use to graph. I need to make sure my axes are set up to appropriate intervals to start with. So my largest x value is 15.8, so I might make this go up to 16. And then my largest y value is 37, so maybe I'll make this go up to 40. These intervals will work. I could make that 2 or 3 or something like that if I'd prefer. And I just need to plot points. So 8.7 and 30. 30 is going to be right there between 28 and 32, so I can start at the 30 and go over to the 8.7. And really, I'm just kind of eyeing it. I know 0.7 is a little more than 0.5, so it's a little further than half, and then it'll snap to the right place from there. This next point, 7.4 and 28.7, might go over to 7. That looks like 7.5, which is close to 7.4. And then I'm going to go up to 28. And I know it's going to be a little bit more than 28, 28.7. And so I go there and it snaps over as long as I'm close. 15.8 is very close to 16. Let's see, 37 would be close there. So I can just kind of click there and it'll go ahead and snap it to exactly the right place. I can draw the line and then I am done with this problem. So I just click I'm done. And that's all. Okay, I hope this helps.